Bismillahirrahmanirrahim. This is the first video on introduction to oil and gas. Oil and gas are natural resources of enormous economic importance. Together, they provide about 60% of all the energy used by society today. They provide fuel for transport and are vital for heating, lighting, and cooking. In addition, they are used in the manufacture of synthetic fibers, plastics, fertilizers, detergent, as well as for many other purposes. In short, it is hard to imagine how our society could function without oil and gas. We are going to cover a wide spectrum of topics in the introduction to oil and gas. In the first video, we are going to talk about the biological and geological processes responsible for the formation of oil and gas. These are the topics that we are going to cover in this video. Please like, subscribe and share my channel to search for accounting lessons and hit the notification bell button to alert you for the latest video. For all of your questions, comments and suggestions, please put them in the comment section below. And for webinar and guest speaker invites, please send me a message at accountingamir@gmail.com. Accounting is AK. We hope that this video help students in their academic development and teachers in enhancing their lesson plans and teaching methodologies. We also hope that this video help fresh graduates who have joined the oil and gas companies and want to refresh their learning on oil and gas accounting. Let us start with how petroleum and natural gas were formed. In the stage 1, all of the oil and gas we use today began as microscopic plants and animals living in the oceans millions of years ago. As these microscopic plants and animals lived, they absorbed energy from the sun, which was stored as carbon molecules in their bodies. When they died, they sank in the bottom of the sea. Over millions of years, layer after layer of sediment and other plants and bacteria were formed. In stage 2, as they became buried over deeper, heat and pressure began to rise. The amount of pressure and the degree of heat, along with the type of biomass, determined if the material became oil or natural gas. More heat produced lighter oil. Even higher heat or biomass made predominantly of plant materials produced natural gas. In stage 3, after oil and natural gas were formed, they tended to migrate through the tiny pores in the surrounding rocks. Some oil and natural gas migrated all the way to the surface and escaped, while other oil and natural gas deposits migrated until they were caught under impermeable layers of rocks or clay where they were trapped. These trap deposits are where we find oil and natural gas today. Let us talk a bit about ancient Earth. Most of the source rocks that give rise to our present day oil and gas fields were formed in the middle of Mesozoic era about 150 million years ago. At that time, conditions were just right to build up huge thickness of black shale. On the one hand, the oceans were unusually warm, promoting vast plankton blooms. On the other hand, oxygen was mostly absent on the ocean floors, so most of the plankton that settled on the bottom accumulated. There were no animals around to eat it up, and the map on the left hand side shows what the earth looked like around 150 million years ago. The red circles show where the world's main oil deposits were formed in warm, shallow, deoxygenated seas. Let us see the source of North Sea oil. A real example of a black shale that was formed a major oil deposit is the Jurassic Kimmeridge clay. This is a 150 million year old shale that contains up to 50% organic matter. It stretches from Dorset in southern England right across to Norway. It was this black shale which was the main source rock for the North Sea oil and gas province. Let us see how oil and gas are made of. Oil and gas are made up of a mixture of different hydrocarbons. A hydrocarbon is an organic chemical compound composed exclusively of hydrogen and carbon atoms. Hydrocarbons are naturally occurring compounds and form the basis of crude oil, natural gas, coal, and other important energy sources. It may come as a surprise, but most of the world's oil and gas is made up of the fossil remains of microscopic marine plants and animals. That's why oil and gas are often referred to as a fossil fuel. One of the most important group of plankton involved in the formation of oil and gas are single-celled marine plants called dinoflagellates, though many types of animal plankton are also important. Some oil and gas may have also originated from the remains of land plants, but we will not discuss these types of deposits in this video. Let us see now what are blooms. In certain parts of the world oceans, plankton occurs in enormous quantities or blooms. Exactly where these plankton blooms occur is controlled by ocean current. The richest sites are where cold, nutrient-rich waters rise to the surface from the deepest part of the ocean. The nutrients found in these upwelling zones feed plankton and allow them to reproduce quickly. A single liter of seawater may contain several million dinoflagellates. Where these plankton occur in high numbers, they may turn the water red, and this phenomena is known as red tide. When plankton dies, it slowly settles to the seabed where it forms an organic mush. Usually, there are lots of animals living on the seafloor that feed on this material. One important group is the polychaete worms. These are detritivores, which means they eat the dead and decay remains of other organisms. Next, we will talk about black shale. Under certain conditions, there may be very little oxygen on the sea floor. This may be because the ocean is deep and stagnant, and oxygen has not been mixed down from the surface waters. No animal life can survive where the seabed is completely lacking oxygen. Without oxygen, without animals to eat the dead plankton, the organic mush builds up on the seabed. Where ocean sediment contains more than 5% organic mush, it eventually forms a rock known as black shale. The black color comes from the dark organic matter that it contains. As we will see, black shale is what makes oil and gas. Let us see how oil is trapped in rocks. So far we have seen that it takes immense amount of time to form oil and gas. Consequently, it is an extremely valuable resource and huge amounts of money are poured in trying to locate new oil and gas fields. In this section, we will investigate how reservoirs of oil and gas are discovered and how it eventually reaches the marketplace. As we have already seen, once produced, oil and gas migrates out of its source rock and accumulates in overlying rocks. Some rocks like sandstone or limestone are permeable. They are permeable to oil and gas, which means that they can pass freely through them. Other rocks like clay or salt are impermeable. Which means that they block the upward passage of hydrocarbons, and you can see that it is blocked in these sections. These are permeable, so that's why oil goes up, but these are impermeable rocks and that's why they have blocked the flow of oil upward. Just keep in mind that oil is lighter in weight than water, that's why it pushes up. So one of the most common ways that oil and gas becomes trapped in these pockets in the rock is where it rises into a structural dome capped by impermeable rock. You can see a kind of dome has been formed over here. The cap rocks prevent the oil and gas escaping upwards. The buoyancy of the less dense hydrocarbons in the pore waters prevent them from sinking back downward. This is an example of an oil trap. Let us talk a little bit on reservoir rocks. The permeable rocks that contain oil and gas within the oil trap are known as the reservoir rocks. Reservoir rocks have lots of interconnected holes called pores. These allow them to absorb the oil and gas like a sponge. The picture on the left side of the screen shows a good reservoir rock with lots of pore spaces filled with water shown in blue. These pores gradually fill with oil. This rock can soak up a large amount of oil. Next, let us talk about different types of oil traps. The first one is the fault trap. Fault trap is a trap formed when the movement of the earth crust causes different rock strata to offset or shear off. This trap is formed by the movement of permeable and impermeable layers of rocks along a fault plane. The permeable reservoir rock faults such that it is now adjacent to an impermeable rock, preventing hydrocarbons from further migration. So that's how the oil is trapped. We have impermeable, we have porous rocks, and the source rocks are there, and this is going to be formed because of movement of the earth's crust. Next, let us talk about anticline trap. Anticline trap is a trap formed by the folding of the earth's crust into a dome. You can see a dome has been created. This upward folding is caused by pressures developed from the earth's molten core. An impervious or non-porous layer of rock overlying the anticline traps the oil or gas in the anticline structure. Most of the Earth's oil and gas reserves are found in anticlines. Next, let us talk about salt dome. Salt dome is a trap created by a bed of non-porous salt pushing upward through overlying formation. Faults in which oil and gas are trapped are created along the sides of the upthrusted salt dome. A salt dome is a type of structural dome formed when salt or other evaporite minerals intrudes into overlying rocks in a process known as diapirism. Salt domes can have unique surface and subsurface structures, and they can be discovered using techniques such as seismic reflection. Next, let us talk about reservoir. In order for conventional oil and gas to be feasible, there must be sufficient quantity of hydrocarbons to justify the cost of production. A reservoir or oil and gas reservoir is a subsurface accumulation of hydrocarbons contained in porous or fractured rock formation. The accumulation is commonly referred to as a reservoir. Four conditions are necessary to the formation of a reservoir: a source of petroleum, conditions such as heat and pressure resulting in the transformation of the organic material into petroleum, porous and permeable rock through which the petroleum was able to migrate after formation, an impervious rock formation that acts as a trap or cap rock, permitting petroleum to accumulate in substantial quantities. So, porosity is the measure of the pore space, either openings in a rock in which petroleum can exist. The greater the porosity, the more fluid petroleum the rock can hold. Permeability measures the connectability of the pores which determines the ability of the petroleum to flow through the rock from one pore space to another. High porosity is often accompanied by high permeability. Next, let us see how crude oil is converted into different types of oil at different temperatures. As more sediment accumulates on top, layers of black shale become buried more and more deeply in the earth crust. As they do so, they slowly heat up because of geothermal gradient. With progressive heating, the organic material in the plankton undergoes chemical and physical changes. It gradually breaks down into smaller and smaller hydrocarbons. At temperature around 30 degrees centigrade, a solid sticky bitumen is produced. Around 90 degree centigrade, liquid oil is formed. As temperature reaches 150 degrees centigrade, natural gases like methane are given off. A black shale that is heated and gives off oil and gas is known in the oil industry as a source rock. Finally, let us see why oil migrates upwards. The hot oil and gas does not stay in the source rock for long. As the hydrocarbons are less dense than the water in the source rocks that surrounds them, they gradually migrate upwards through the rock in much the same way that the less dense air bubbles of an underwater diver will rise through the water. The migrating oil and gas may travel up through the spaces between the sand grains that makes up the rock called pores, or they may find their way up through cracks, fissures and faults in the overlying rocks. As we have seen, oil and gas get trapped in the pockets of rock known as reservoirs. So this completes part 1 on introduction on oil and gas, where we have talked about the origin of petroleum. Remember, effective questioning brings insight, which fuels curiosity, which cultivates wisdom. If you have any question regarding this session, then please don't hesitate to ask in the comment box or by email, and inshallah I will reply you back. Thank you so much and happy learning.